Continuing our series of videos on exponent rules, today we're going to look at I can divide powers that have the same base. And we're going to come up with an example here so we can look at some of the properties of what happens when you divide exponents. We have x to the fourth divided by x to the second. We can rewrite that in its expanded form. X to the fourth becomes x times x times x times x. And in the denominator, x squared becomes just x times x. When we divide things that are the same, something that's the same in the numerator and the denominator, they divide to become 1. In other words, they cancel out. So the first x here in the numerator and the first x here in the denominator can divide away to become 1. The second x in the numerator and the second x in the denominator does the same, divides away and becomes 1. And so what we're left with is just 2 x's in the numerator multiplied together, in other words, x squared. Now you may notice that there's a bit of a pattern here. X to the fourth divided by x to the second. If we take those two exponents and we subtract them from each other, we get the same exponent as we did in our answer. And so this can become rule number 4 of dealing with exponents. When we divide powers with the same base, you should subtract the exponents. Let's see what that looks like in practice. Problem number 1, we have x to the fifth divided by x to the third. Notice they have the same base. They both have a base of x. So if we want to divide them, we can just use our rule number 4 and subtract the exponents. 5 minus 3 is 2, and so we get an answer of x to the second. In number 2, we have the same thing, except we have lots of different exponents with lots of different bases. So we'll divide the things that have the same base, such as x to the sixth and x squared. When we divide those from each other, we subtract the exponents. 6 minus 2 gives us x to the fourth. We'll do the same thing with the y's. We have y cubed divided by y to the first. There's no exponent, it's a 1. And so we end up with y to the second power. 3 minus 1 is 2. And then finally we have a z here all by itself, and so it will remain just a z to the first. In number 3, we've introduced some constants, so we'll divide those just like we would any other numbers, just like when we're dealing with fractions back in middle school. 27 divided by 18, I believe 9 goes into both of those, and so we end up with 3 over 2. 27 divided by 9 is 3, and 18 divided by 9 is 2. We'll handle the exponents the same way we've been. The m's are the same base, so m cubed divided by m squared. We'll subtract the exponents. 3 minus 2 gives us m to the first. And the same thing with the n's. N to the eighth divided by n to the fifth. We'll subtract the exponents and get n to the third. And we can rewrite our answer just to look a little nicer. 3 m to the first, n cubed, all divided by 2.